This pull-out test was performed using a long-ribbed reinforcement bar embedded to almost the full depth of a concrete cylinder. The concrete cylinder was not reinforced with mesh, and as such was predicted to fail explosively. As the machine began to pull the steel from the concrete, there was not much displacement to be seen. The load increased gradually, reaching a maximum at about 48 kilonewtons. After this, the load began to reduce and suddenly dropped from 44 kilonewtons to 0. This sudden drop in load value was due to the failure of the reinforced concrete element. This next clip shows an overview of the sample failing. As it is possible to see, the concrete suddenly cracks around the steel reinforcement bar. This shot shows a close-up view of the steel displacement at failure. It is possible to see that the steel has not been pulled from the concrete in the lead-up to failure. However, at failure the steel suddenly pulls upwards as the concrete splits. These pictures show the failure of the reinforced concrete specimen which has been removed from the testing machine. Due to the way that this element failed, it is possible to conclude that the maximum load before failure was not that of the bond between the steel and concrete. Instead, it was the concrete itself that was not strong enough to resist the load and thus failed by splitting. In order to obtain a value for the strength of the bond, the concrete would need to be reinforced. The anchorage of the steel was not affected by the load until the concrete failed. Thus, reinforcing the concrete would give a more accurate value of the anchorage strength.